Good afternoon, dear students. I hope you're all doing good. In this video, I'm going to start with a new chapter, that is chapter 11, calorimetry. Okay, so before we go to the concept of calorimetry, first we have to understand certain terms, that is heat. Let us look at the concept of heat first. Okay. Now we know each substance is made up of molecules. We have learned in lower classes as well. Every substance is made up of molecules, isn't it? Now the molecules are not in the state of rest, but they are in constant random motion, and there is a force of attraction between the molecules, isn't it? So the molecules are in constant random motion, as well as they have the forces of attraction between them. So the molecules possess kinetic energy due to their random motion, and they possess potential energy due to the attractive force that exists between the molecules. So in molecules, we have kinetic energy, which is due to the random motion of molecules, and we have potential energy due to the attractive forces that exist between the molecules. Okay, so the molecules in a substance has both kinetic energy and potential energy. Now, the sum of kinetic energy and potential energy of a molecule is known as its internal energy. That is, internal energy is equal to the sum of kinetic energy and potential energy. Okay, so internal energy is the sum of kinetic energy and potential energy of a molecule. Now, the total internal energy of the molecules of the substance is known as heat energy. Okay, what is heat energy? Heat energy is the sum of internal energy of molecules. Heat energy is the sum of internal energy of all the molecules in a substance. So we know what is heat energy. Now let us say two bodies, one is of hot body and one is cold body. When two bodies having different temperatures are kept in contact, what happens? The internal energy will flow from a hotter body to a colder body. Okay, so there is a flow of energy from a hot body to a cold body when they are kept in contact, and this energy which flows from a hot body to a cold body when they are kept in contact is known as heat energy, or simply heat. So heat energy, heat can be defined as the internal energy of molecules constituting the body, and this heat energy flows from a hot body to a cold body when they are kept in contact. Okay, so we have to remember that heat always flows from a hot body to a cold body when the two bodies are kept in contact. Okay, now since heat is a form of energy like other energy, it is a measurable quantity, and this calorimetry is the measurement of the quantity of heat. Okay, the measurement of the quantity of heat is known as calorimetry, which we are going to learn in this chapter. Now next, let us look at the units of heat. Units of heat. We have said heat is a form of energy, As we know, the SI unit of energy is joule, so the SI unit of heat is also joule. SI unit of heat is joule, and it is denoted by capital letter J. Okay, there are some other common units as well. The other units of heat are calorie, which is denoted by CAL, and kilocalorie. These are the other units of heat. Now let us define calorie. Okay? 1 calorie is defined as the quantity of heat energy required to raise the temperature of 1 gram of water by 1 degree Celsius. In this definition, we have assumed that the heat energy required to raise the temperature of 1 gram of water to 1 degree Celsius is the same at each initial temperature. But this definition is not true because of the non-uniform thermal expansion of water. We have learned in lower classes about the anomalous expansion of water, isn't it? So due to the non-uniform thermal expansion of water, this definition is not true. We have another precise definition of calorie, that is 1 calorie is defined as the quantity of heat energy required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. Let us write down. One calorie is defined as the quantity of heat energy required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. In the previous definition, we have said it is the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius. But this is the precise definition of 1 calorie. You might be thinking why we use this range of temperature. This is because of the non-uniform thermal expansion of water, that is the anomalous expansion of water, which means that the water does not show constant expansion till it reaches 14.5 degrees Celsius. So to make it precise, we use this temperature range. Okay, so this is calorie, and this calorie is a smaller unit of heat, and the bigger unit of heat we have kilocalorie, which is written as KCAL. And this unit of heat is generally used to measure the energy value of foods. Okay, now the SI unit of heat is joule, and we have another unit that is calorie. So this joule and calorie are related by certain equation. We have 1 calorie is equal to 4.186 joule. Okay, 1 calorie is equal to 4.186 joule, and this is nearly equal to, we can round off this number to 4.2 joule. Okay, so we have the relation 1 calorie is equal to 4.2 joule. This is a very important relation. Okay, now the bigger unit is kilocalorie. So 1 kilocalorie 1 kilocalorie is equal to 1000 calorie, which is equal to 4200 joule. Okay, 1 kilocalorie is equal to 4200 joule. This is the relationship between the different units of heat. Now, how can we define 1 calorie? Let us define 1 calorie. 1 calorie is defined as the amount of heat energy required to raise the temperature of 1 kilogram. In place of gram, since it is kilocalorie, we will have 1 kilogram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. Now, next, let us go to the concept of temperature. We often have confusion between heat and temperature. We thought heat and temperature are the same, but actually they are completely different terms. Now, let us study the concept about the temperature. Temperature and heat always go hand in hand. Now, when two bodies are kept in contact, having different temperatures, what will happen? The heat will flow from a hot body to a cold body until they attain the same temperature, isn't it? Now, if this is a hot body and this is a cold body, okay, when these two bodies are kept in contact, all right, what will happen? The heat will flow from a hot body to a cold body. Heat flows will be from a hot body to a cold body, isn't it? Now, the body which imparts heat, which means the body which gives heat, is said to be at a higher temperature. And the body which accepts heat or receives heat is said to be at a lower temperature. All right. Now, what do we get from this information? We get the information of temperature. So temperature determines the direction of flow of heat, isn't it? So since heat always flows from a hot body to a cold body, and the body which imparts heat is said to be at a higher temperature, and the body which receives heat is said to be at a lower temperature. So temperature determines the direction of flow of heat. Okay, and this cold body, the body which receives, after it receives heat, what happened to the molecules of the body? They will move more vigorously, okay, and there will be a rise in its temperature. All right, so temperature can be defined as, it is a parameter or a quantity that tells us the state of the thermal, that tells us about its thermal state. That is, it tells us the degree of hotness or coldness of a body. And temperature also determines the direction of flow of heat. Okay, now when the two bodies are kept in contact, we have said that heat flows from a hot body to a cold body. Now, if the two bodies are kept in contact, but there is no heat flow between the two bodies, we said that the two bodies are at the same temperature, or they are in thermal equilibrium. Okay? Though the two bodies have the same temperature, it does not mean that the two bodies have the same amount of heat. They may have different amounts of heat. Okay, so the heat contained in a body depends on three factors. Number one, the heat contained in a body depends on the mass of the body. Number 2, it depends on the temperature of the body. And number 3, it depends on the material or substance of the body. Okay, now let us look at the units of units of temperature. Units of temperature. The SI unit of temperature is Kelvin. And Kelvin is written in capital letter K. The SI unit of temperature is Kelvin. We have other common unit. Other common unit of temperature is degrees Celsius. And degrees Celsius is written as this. Okay, so it is other common unit is degree Celsius. Now there is a relationship between Kelvin and degree Celsius. If T is the temperature in Kelvin, we have 273 plus T degree Celsius. This is the relation between Kelvin and degree Celsius, which means that if I have a temperature given in degrees Celsius, I can convert it to Kelvin by adding the temperature in degrees Celsius with 273. Okay, so this is the important relation between Kelvin and degrees Celsius. Now, the zero of the Kelvin scale, that is 0 Kelvin. 0 of the Kelvin scale, 0 Kelvin is known as absolute zero. It is known as absolute zero temperature. Okay, and 0 Kelvin or absolute zero is the lowest temperature that is possible in nature. We cannot have any temperature which is lower than 0 Kelvin. And 0 Kelvin is equivalent to minus 273 degrees Celsius. We cannot have any temperature lower than 0 Kelvin or minus 273 degrees Celsius. So what happened to the molecules in the substance at 0 Kelvin? At 0 Kelvin, the movement or the motion of molecules ceases. That means there is no motion of molecules when it comes to 0 Kelvin. Okay, and in the Kelvin scale, no negative temperatures is possible. All right, the lowest temperature in the Kelvin scale is 0 Kelvin, which is also the known as absolute zero, the lowest possible temperature possible in nature. Okay, so this is about the relationship between Celsius and Kelvin. Heat absorbed by a body to increase its temperature. There are 3 factors which affects the heat absorbed by a body to increase its temperature. Number 1 factor is the mass of the body. Okay, mass of the body. Now let us consider objects having different masses which is made of the same substance are to increase its temperature by 1 degree Celsius. Then the heat absorbed by the 2 objects having different masses will be different. All right, so to understand this, let me show you an example. Let us consider an example. Let us take a substance, water. Water which is 1 gram of water and 2 gram of water. Okay, they are made from the same substance and their masses are different. One is of 1 gram and the other is of 2 gram. Suppose I want to raise its temperature by the same amount, that is 1 degree Celsius. Now, the heat absorbed by 1 gram of water to increase its temperature by 1 degree Celsius is equal to 1 kilo kilocalorie. Okay, so 1 kilocalorie heat will be absorbed by 1 gram of water to increase its temperature by 1 degree Celsius. All right, now water which is 2 gram, to increase the temperature of 2 gram of water by 1 degree Celsius, the heat absorbed will be equal to 2 kilocalories. All right, so though they are made of the same substance, because of their difference in their masses, the heat absorbed by them will be different. One is 1 kilocalorie and the other is 2 kilocalorie. So from here, what do you see? That as the mass is increased, the heat absorbed will be increased. That means more the mass, more will be the heat absorbed by the body. Okay, so we see that the heat absorbed, if Q is the heat absorbed by the body, Q is directly proportional to the mass. All right, which means that the heat absorbed is directly proportional to mass. More the mass of the body, more will be the heat absorbed. All right, this is the first factor. Now the second factor is the increase in the temperature of the body. The increase in the temperature of the body. Now let us take objects which have equal mass and it is made of the same substance. Now these two objects are, we want to raise its temperature by 1 degree Celsius and 2 degree Celsius. I have two objects having equal mass and they are made from the same substance. All right, so if I want to raise its temperature by 1 degree Celsius and this one by 2 degrees Celsius, what will happen? The heat absorbed by these two objects will be different because of their difference in the increase in its temperature. Now let us take example. Let us consider a substance, water. Okay, now 1 gram of water, if I want to raise its temperature by 1 degree Celsius, the heat absorbed will be equal to 1 kilocalorie. And if I take 2 grams of 1 gram of water and I want to raise this 1 gram of water by 2 degrees Celsius, then the heat absorbed will be equal to 2 kilocalorie. Okay, so from this example, what do we see? Since there is a difference in the rise or increase in its temperature, the heat absorbed by the two objects will be different. And we also see that if the rise in temperature is more, then the heat absorbed will be more. Okay, so we can write Q, the heat absorbed. If heat absorbed is Q, it is directly proportional to the rise in temperature. If delta T is the rise in temperature, Q is directly proportional to the rise in temperature. So if more the rise in the temperature, more will be the heat absorbed. This is the second factor. Now the last and third factor is the material or substance of a body. Now, the heat absorbed by a body to increase its temperature also depends on the material or substance of a body. Now, let me take one example. Let us consider two substances, water and copper. Okay? If I consider two substances, water and copper. Now I want to raise both these substances by 1 degree Celsius. Let us take same or equal mass. All right. I take two substances, water and copper, of equal mass, and I want to raise its temperature by 1 degree Celsius. We will see that the heat absorbed by water is nearly 10 times the heat absorbed by copper. Okay, so the heat absorbed will be different by both the substances because of the difference in the material or the substance. And this is given as the specific heat capacity. The heat absorbed is directly proportional to the material or substance of the body. All right, and now let us sum up this. From these three factors, what do we see? Number one, the heat absorbed depends on the mass. And number two, the heat absorbed depends on the rise in temperature, delta T. And number three factor, it depends on the material or the substance of the body, that is C. Okay? So, I have Q equal to M C M delta T. And C here is the material or substance of a body, and it is also known as constant of proportionality, and it is called specific heat capacity. It is called specific heat capacity. The specific heat capacity is the characteristic property of a body, and this specific heat capacity is different for different substances. Okay, so this is all for this topic. Now, let us see the differences between heat and temperature. You can follow me in your book, page number 263. Let us look at the differences between heat and temperature. The first difference is that heat is a form of internal energy. It is a form of internal energy. It is obtained due to the random motion and attractive forces between the molecules of a body. Okay? And temperature. Temperature is the quantity which determines the direction of flow of heat, and it also tells us the degree of hotness or coldness of a body. Okay? And the second difference is that the SI unit of heat is joule, and the SI unit of temperature is Kelvin. Okay? The third point, the amount of heat contained in a body depends on mass, temperature, and substance of a body. So the amount of heat contained in a substance depends on the mass, its temperature, and the material of the body. And number three, the temperature of a body depends on the average kinetic energy of its molecules due to their random motion. Okay? And number four, heat is measured by the principle of calorimetry, and temperature is measured by an instrument, thermometer. Okay? And the next point is that two bodies having same quantity of heat may differ in their temperature. And in temperature, two bodies having same temperature may differ in the quantities of heat contained in them. Okay, and the last difference, point number 6, when two bodies are placed in contact, the total amount of heat is equal to the sum of the heat of the individual body. And in temperature, when two bodies at different temperatures are kept in contact, the resultant temperature is the temperature in between the two temperatures. All right, the resultant temperature is a temperature in between the two temperatures. So these are the differences between heat and temperature. So this is all for today's video. Thank you.